Hello, and welcome to today's HCPA training. Today we'll cover pre-sales training for the Huawei Fusion Server E9000 V5 Converged Architecture Blade Server. We will discuss the latest information about the E9000 Blade Server progress and products. Today's training consists of three parts. Firstly, let's take a look at the trend and progress of the entire market. Next, we'll look at product highlights, and finally, we'll cover some cases and application scenarios. With the continuous improvement of data center integration, data center infrastructure goes through different phases of development. As shown in the figure on the right, the earliest data center is server-centric, and storage is built in servers. Later, storage is separated from servers and becomes independent SAN and NAS. Then, a storage and server-centric infrastructure is formed. Next up is the third phase. Networks of the same data center are unified to form Ethernet-based FCOE and other types of networks. Next, according to some forecasts from analysts in the industry, we believe that the converged infrastructure will become a development trend in the industry. Convergence refers to computing, storage, and network resources convergence. Even management and service software are integrated with products. Huawei E9000 Blade Server is a converged architecture blade server that integrates computing, storage, and network resources. Thanks to its high integration and smooth expansion, the E9000 is an ideal choice for customers to implement highly integrated deployment. Why blade servers? We know that many customers are using rack or high-density servers. In particular, rack servers are the most widely used servers. Given that rack servers are cheaper and more widely used, why would customers choose blade servers? Well, let's take a look at the comparison. The E9000 is a 12U rack with a maximum of 16 blades and 4 switch modules at the back. The computing and networking process capabilities of a single E9000 are equivalent to those of 16 2-socket rack servers plus 4 switches. We can see that the performance of one E9000 server is equal to that of 16 2-socket servers plus 4 switches, and the E9000 occupies only 1/3 of the equipment footprint. Therefore, the integration of the E9000 blade is higher. What's more, the E9000 uses fewer PSU and fan modules, that is, only about 20 to 10% of those of a rack server. As for cables, if we deploy 16 rack servers in a cabinet, a large number of cables are required for connection, including management port cables and data cables. In this case, a lot of work would be required for cable connection. And what's more, cables will usually cause more faults. Things are different in the E9000 server. It uses a mid-plane to replace internal switching cables, significantly reducing the number of cables required. We can see the traditional service requires about 96 cables, but the blade server requires 0 cables. This also improves the reliability of the entire system. Another advantage of the E9000 is its easy deployment. Thanks to its high integration and support for some features that improve management and deployment efficiency, the E9000 server requires much less deployment time and configuration time than those of rack servers. To sum it all up, blade servers can greatly reduce OpEx, power consumption, and the equipment footprint for customers. If customers are concerned about the equipment footprint of the entire infrastructure and the O&M efficiency, they can choose blade servers, which have great advantages in these perspectives compared with traditional rack servers. In fact, Huawei has been working on blade servers for nearly 15 years. Back in 2003, we started to develop our first carrier-class blade server. At the beginning, we developed the T8000 carrier-class blade server, which is mainly used in core network and application and software domains by customers such as China Mobile, China Unicom, and China Telecom. In 2006, we launched our first-generation enterprise-level blade server, which was called the E6000, using a 6U chassis. In 2012, about the time the Enterprise BG was built, we launched our E9000 Converged Architecture Blade Server. Looking at shipment volumes inside and outside of China, Huawei E9000 is among the top of the blade server industry. We are a mainstream player. Huawei's blade server shipment volume ranked number 4 globally and ranked number 1 in China. These statistics are sourced from Gartner's latest shipment volume report. Huawei's E9000 is among the best in the market. Most blade server customers will consider the E9000 server. It's clearly quite the popular server, so now let's take a look at the highlights of the E9000. We know that the entire x86 server industry has entered a new era since Intel launched its latest generation scalable processors in July of 2017. Huawei calls this era the V5 era. At the same time, Huawei launched the E9000, which is our latest generation V5 blade server. Thanks to the specific heat dissipation design and overall hardware design, the E9000 supports rip and replace upgrades to the Intel scalable processors without changing the chassis. This means a significant infrastructure cost reduction for customers because customers can smoothly and seamlessly upgrade their service to V5 blade servers without considering the chassis. From the perspective of the entire product, the E9000 has 4 highlights, as shown on the right: leading performance, high-speed network, smart management, and ultimate reliability. First, let's analyze the leading performance of the E9000 from the CPU, hardware acceleration, memory, and storage perspectives. Firstly, the E9000 V5 supports all power specifications, with a highest power of 205 watts, which is much higher than the 165 watts of V4. the high CPU power poses a great challenge to the design of the server. We know that blade servers are generally more space constrained, and they have a higher density, which causes difficulty when it comes to heat dissipation design. Some other products, for example the HP C7000 and Dell M1000E, do not support CPUs that are 165 watts or above. They can only support CPUs with medium or lower power consumption. This puts customers at a disadvantage because they cannot use high-performance CPUs. However, Huawei E9000 supports all 205 watt CPUs. Secondly, our E9000 servers support standard half-height, half-length PCIe cards. Customers can use various cards such as FPGAs and GPUs to support hardware acceleration such as compression and decompression, encoding and decoding, and some security encryption and decryption protocols. The PCIe card of this generation incorporates a special design different from that of the previous generation. That is, it supports independent front cabling. We can directly provide the PCIe card cable on the front panel of the blade. Some customers have such a unique requirement. In addition, the PCIe card of this generation does not occupy a DIMM slot, while the PCIe card of the previous generation occupies 6 DIMM slots. A single CPU supports 6 channels of memory. Therefore, a dual-socket blade server supports 12 memory channels, 50% more than 8 channels supported by the previous generation. This enables a server to bring much higher performance for scenarios that have higher memory requirements, for example, SAP HANA and in-memory computing. As for the AEP memory, it requires CPU support. Currently, Intel has not released a CPU that supports AEP memory. When it does, our server will also support the new AEP memory. As for storage, we have a huge upgrade in this generation, that is, we now support M2 SSDs. Our 2-socket blade server supports M2 SSDs, and our 4-socket blade server supports 8 M2 SSDs. M2 SSDs can be used for operating system installation and log file storage. M2 SSDs are equivalent to SATA SSDs, but deliver higher performance. This slide shows the exceptional performance of the E9000. Performance has always been an advantage of Huawei servers. So far, we've broken more than 300 performance records in benchmark tests organized by different standards organizations, including spec tests and VMark tests. In this V5 generation, our CH121 V5 blade has broken 2 spec test records, including the spec floating point performance record. That is, our blade delivers the highest performance in the blade domain. The data source of these 2 performance records is also provided at the bottom of the slide. You can visit this website to learn more about the tests if you are interested. The E9000 consistently shows advantages in the network because Huawei was a network product developer at the very beginning, and therefore we've been closely working with the Huawei data communication product line. The versions of most switches and switch modules used in the E9000 are the same as those versions that are used for data communication products, and some new features are available as well. Here are 4 new switch modules. The CX620 and CX621 are 100 gigabit InfiniBand EDR switch modules. The CX620 and CX621 have the same hardware specifications and differ only in the chip. Compared with the CX620, the CX621 supports more software features. The CX820 is a newly launched V5 OPA switch module and also an OmniPath switch module promoted by Intel. The OPA is mainly used for HPC and financial transaction scenarios that have high requirements for latency. The CX820 is also a 100G OPA switch module. As we all know, the CX9XX series are multiplane switch modules. A multiplane switch module supports both the Ethernet plane and the FC plane, and the 2 planes are mutually independent. The CX916 is a multiplane switch module that supports 25G and 16G FC. Launched in the previous generation, the CX320 will continue to serve as a major switch module for a long time. In the future, some CX3XX series switch modules will be replaced by CX320s. Both GE and FCOE functions can be implemented on the converged switch module CX320. As mentioned before, the 100G IB, EDR, and OPA are already supported. It's estimated that the 100G switch module can be delivered in the second half of 2018. And therefore, E9000 is the most comprehensive solution in the industry for customers to select 100G networks as required. The second highlight is multiplane networking. What does multiplane networking mean? Well, each Huawei V5 blade provides 2 10GE LOM ports. Some customers require multiple planes to isolate the data plane from the management plane or isolate east-west traffic from north-south traffic. Under these requirements for highly reliable networking, customers expect as many planes as possible. The LOM ports of E9000 V5 blades can spare the mezzanine cards in extreme cases, reducing customers' networking costs. The third highlight is SDN. SDN has gradually been used by key carriers and internet customers. The CX320, CX710, and CX920 support SDN and can be managed by Huawei's Agile controller. Currently, Huawei switch modules do not support controllers developed by third parties. The fourth highlight is converged switching. For example, the CX320 converged switch module flexibly supports 10GE and FCOE. The CX916 multiplane switch module supports 25G and 16G FC, providing flexible interface types for customers. This slide takes a look at multiplane networking. As shown in the figure on the left, the LOM is the onboard network port which can directly connect to a 10G port or connect to an FC mezzanine card and then to a 16G FC port. The CX916 serves as a rear switch module. The lower half of the figure shows two configuration options. If configuration 1 is selected, only one NIC and one pair of switch modules are required. For competitors, at least two NICs and two pairs of switch modules are required. Therefore, Huawei is more competitive than competitors in terms of cost. The CX920, which will soon be replaced by the CX930, in configuration 2 also supports the motherboard network ports 40G and 16G FC. Competitors are incapable of providing this solution currently. However, Huawei can use CX920s and CX220s to support 10G, 40G, and 16G FC. Apart from these two competitive configurations, Huawei also provides other advantageous configurations. For example, the CX916L may be launched in the future to spare the FC plane and reduce the cost. The LOM port can directly connect to the Ethernet plane, sparing the mezzanine card and further reducing the cost. This slide shows the benefits of LOM. The first benefit is multiplane networking. As mentioned before, multiplane networking provides one more network plane than traditional networking formed by two mezzanine cards. This feature has great advantages in solutions requiring high reliability, such as north-south traffic isolation and data management plane isolation. The second benefit is its rich network features. Based on the Intel PCH bridge chip solution, the LOM port supports more features, such as iWarp, which is similar to RDMA, than traditional mezzanine cards. The LOM also brings two benefits in terms of hardware. The LOM does not require connectors or mezzanine cards, greatly reducing the failure rate. The second benefit is power consumption reduction, as shown in the lower right corner. Compared with the PCH mezzanine card solution, the solution with PCH integrated on the NIC consumes about 23% less power. This page describes the advantages of the E9000 in management. Compared with rack servers and high-density servers, blade servers have one major advantage: centralized management. Many features can be integrated into the centralized management module, such as the repeatedly publicized features Stateless Computing and EasyLink. For V5 management modules, we will continue optimizing the stateless computing and EasyLink features, but a big difference is that the management module may integrate with eSite management software. Please pay attention to the asterisk, which means that this feature may be available at the end of 2018 and may be implemented based on Director software. The upper layer management software is integrated into the management module and built into the chassis to support more features. The E9000 V5 server supports the new generation RESTful APIs and also mainstream management interfaces such as SNMP interfaces and IPMIs. It is also compatible with the Intel RSD architecture, and this feature is mainly promoted to carriers and internet customers. Entire lifecycle management is implemented through a combination of the BMC and eSite software. The entire lifecycle of the server, from planning, delivery, O&M, and out of service, can be managed intelligently. Delivery tools are provided for different phases, improving the management efficiency by about 50%. The last feature is FDM, which is similar to that of rack servers. The E9000 V5 server supports 93% or higher fault pre-warning accuracy. It supports precise FDM, especially for the CADR faults that are difficult to locate, such as faults in the CPUs, PCIe devices, and memory. This feature is difficult for other competitors in the industry to implement. If a PCIe device is faulty, a server without the FDM feature may consider that the CPU is faulty and generate a false alarm because many PCIe devices are directly connected to the CPU. Besides, faulty devices cannot be located, affecting fault analysis and recovery. Based on the long-term accumulation of fault expert library and intelligent diagnosing technology, Huawei launched the FDM feature to greatly improve the fault locating accuracy and quickly collect information and locate bottom-layer hardware faults. This page shows the highlights of eSite. eSite focuses on entire lifecycle management, such as batch OS deployment and automated upgrade of the BIOS and firmware. On this slide, we'll cover one of our traditional advantages, that is, stability and reliability. Huawei blade servers have claimed to run stably at high temperatures of up to 40 degrees Celsius. The classic case of China Railway demonstrates this advantage well. When the servers of other vendors in the same equipment room became faulty due to high temperatures, Huawei blade servers can still run properly and allowed the freight dispatching system of China Railway to run stably. We can see that Huawei blade servers have been optimized in terms of reliability. According to statistics collected by our top 4 customers, the failure rate of Huawei servers is about 15% lower than that of the industry average. What fault locating and reliability design measures have been taken to lower the fault rate and improve reliability? Well, measures include efficient heat dissipation, redundant design, stringent reliability tests, and end-to-end quality control. Another point that I'd like to emphasize here is the passive backplane, which greatly reduces backplane failure rates. Failure of the backplane is generally high if it is configured with resistors, capacitors, or ICs. On this page, we can take a look at the E9000 product portfolio. We now know that there are 7 models of V3 compute nodes for the E9000. Huawei has launched 3 models of V5 compute nodes: the CH121V5, which is a half-width 2-socket compute node, the CH121L V5, the liquid-cooled version of the CH121V5, and the CH242V5, which is a full-width 4-socket compute node. We have been promoting V5 compute nodes in 2018, and the V3 compute nodes will generally reach EOM at the end of 2018. The upper part of this page shows the chassis. The 12U-high E9000 chassis can provide 8 full-width slots or 16 half-width slots. The middle part shows compute nodes, which we just covered. Currently, 3 models of V5 compute nodes and 6 models of V3 compute nodes are available. The lower part shows the switch modules, which are located at the rear of the chassis. As a V5 model can be used to replace multiple V3 models, the total number of V5 switch models is less than that of V3 ones. We mainly promote the CX320, CX820, and CX916. The CX320 is a converged switch module. The newly launched OPA 6820 is used for HPC and financial transaction scenarios requiring low latency. The CX916 is a multi-plane switch module. Now let's take a look at the chassis. The figure on the left shows the front view of the chassis. An E9000 chassis houses 16 half-width compute nodes or 8 full-width compute nodes. There are 4 switch module slots in the rear, which are numbered 1E, 2X, 3X, and 4E from left to right. The E9000 has 2 management modules. The 6 PSUs are numbered 1 to 6 and located on the outermost side. The E9000 also has 14 fan modules. There is a touch LCD at the bottom of the chassis, which can be used to set and display some basic information such as the IP address. As for the PSUs, N+N or N+M redundancy is supported. The latest titanium PSUs support both AC and DC. Another point I'd like to emphasize is the support for Intel CPUs. As mentioned before, the overall heat dissipation design of the E9000 is excellent. This is why we use a 12U chassis instead of the 10U chassis used by other vendors in the industry. The 12U chassis offers larger slots for compute nodes and has a better heat dissipation effect, supporting CPUs and components that have higher power consumption. This way, the E9000 is capable of supporting the next 3 generations of Intel CPUs and the next decade network technology evolution. For example, the E9000 V5 chassis supports Skylake CPUs with up to 205 watts of power consumption. However, the chassis of many competitors in the industry only support 165 watt CPU power consumption due to limitations of the heat dissipation design. In addition, there are no next generation blades for HP C7000 and Dell M1100 servers. HP and Dell do not have evolution plans for next generation blades. However, the E9000 server supports the next 3 generations of CPUs, making customers' investments all the more worthwhile. Next, let's take a look at V5 blades. The first model is the most commonly used half-width 2-socket blade, the CH121V5. Before introducing this blade, I'd like to describe the naming rules first. The first digit 1 indicates that the blade is a half-width one, and the second digit 2 indicates that the blade is a 2-socket one. That is, the CH121 is a half-width 2-socket blade. It is the most commonly used general-purpose blade. This blade supports full series 205 watt Skylake CPUs and is fully configured with 24 DIMMs and 12 memory channels. The blade also supports a standard card. A half-height, half-length PCIe standard card slot can be used to install an FPGA card, GPU, or IB network adapter. The 2 hard disk slots can be used to install 2 2.5-inch hard disks, 2 NVMe SSDs, or 4 M2 SSDs. Different from other vendors, Huawei provides a dedicated M2 ejector level on the front panel so that customers can perform hot swap on the front panel. Its final highlight is LOM ports for multi-plane networking. This slide shows the specifications of the CH121V5. The highlights of the CH121V5 compared with CH121V3 are marked in red. Take the processor as an example. New generation CPUs support a maximum of 28 cores and up to 205 watts of power consumption because of the performance improvements of Skylake. Both CH121V5 and 121V3 support 24 DIMMs, but CH121V5 supports 4 more channels than CH121V3 and therefore has a higher memory bandwidth. The difference in storage of the CH121V5 supports M2 SSDs. For CH121V3, the PCIe card occupies 6 DIMM slots. For CH121V5, the PCIe card is front accessible and does not occupy any DIMM slots. The biggest change in the network is that LOM ports are supported. The second model is the CH242, which is a full-width 4-socket blade. It is mainly used in mission-critical scenarios such as database, EPR, and SAP HANA. Same as the CH121, the CH242 also supports full series Skylake processors and is fully configured with DIMMs. That is, 48 DIMMs and 24 memory channels are provided. The blade supports a standard PCIe card. The storage capacity of the CH242 is twice that of the CH121. The 4 slots can be used to install 4 2.5-inch hard disks or 8 M2 SSDs. The CH242 V5 supports the LOM and can work with mezzanine cards to form a multi-plane network. This slide shows the comparison between CH242 V5 and CH242 V3 specifications. Major changes are as follows. First, the number of memory channels increases, and M2 SSDs are supported for storage. Then expansion PCIe slots are provided, releasing the space for DIMM slots, and the PCIe slots can be provided at the front. The last change is in the LOM network. The CH242 V5 supports two 10GE LOM network ports to form a multi-plane network. The CH121L V5 is a liquid-cooled version of the CH121 V5, in which an L is an abbreviation for liquid. It is a high-performance liquid cooling blade and is mainly used in liquid cooling situations. The blade supports board-level liquid cooling, which places some heatsinks and liquid cooling devices on boards instead of completely relying on cabinet doors. In comparison, our competitors still use common blades and implement liquid cooling on the cabinet doors. Huawei V5 blades support liquid cooling throughout the cabinet. The specifications of the CH121L V5 are the same as those of the CH121 V5, except that the CH121L V5 does not support PCIe card expansion. Now let's have a look at the cabinet-level liquid cooling solution. When it comes to this, we have a big advantage, that is, liquid cooling is implemented throughout the cabinet. Therefore, heat generated within the cabinet can be 100% dissipated. Previous V3 servers do not support 100% heat dissipation through liquid cooling, and some air-cooled devices must be used, such as chassis fan modules and row air conditioners. Now the V5 servers support cabinet-level liquid cooling and no longer need the row air conditioners. A row air conditioner is configured for a row of cabinets, and conditioners are used in most traditional data centers. Now with cabinet-level liquid cooling, water chillers for row air conditioners can also be saved, which involve huge investments and are a great source of power consumption. Roughly calculated, the liquid cooling solution can reduce power consumption by about 90% and TCO by almost 30%, with a PUE smaller than 1.1. Although liquid cooling involves a larger initial investment than traditional air cooling, according to calculations, investment can be recovered within 2 to 3 years thanks to the electricity costs that you save. Our solution uses warm water for liquid cooling, as is a common practice in the industry. This is because of the energy efficiency of warm water, as it does not need to be cooled a second time and thus saves energy. Now the highest water temperature supported is 45 degrees Celsius. Now we've talked about the blades, let's look at switch modules. The CX916 is a multi-plane switch module that supports both Ethernet and FC, including 16G FC. The CX916 supports a maximum of 8 10GE or 25GE ports, 2 40GE ports, and 1 flexible NIC for port expansion. The switch module also supports 8 16G FC ports. The SDN is supported in Ethernet networking and can be managed by Huawei Agile Controller. Currently, the flexible NIC cards support only 4 10GE ports. In the future, more flexible NICs, such as 25GE or FCOE cards, can be configured based on service requirements. This allows users to flexibly select the port type and quantity for network expansion. This slide shows the comparison between the CX916 and its previous generation multi-plane switch module CX912. We can see that the CX916 has integrated many changes. It supports 25GE and 40GE and the latest 16G FC. Another change is that the CX916 supports flexible NIC, delivering greater flexibility. In addition, the CX916 supports LOM network planes. The Ethernet is directly connected to LOM ports over the V5 blades, eliminating the need for mezzanine cards. Previous switch modules do not support LOM planes. Now with these LOM planes, networking costs can be greatly reduced. The CX820 is a 100G OPA switch module based on the Intel OmniPath architecture. Its downlink bandwidth is 100 gigabits per second per blade. The downlink bandwidth of each blade is the bandwidth between the switch module and the blade, and the uplink bandwidth blade is the bandwidth between the switch module and the devices outside the chassis. The uplink bandwidth is 2000 gigabits per second, and the port latency is less than 100 nanoseconds. In addition, some routing features provided by Intel are also supported. The OPA function is mainly used in HPC scenarios as well as real-time financial transactions such as high-frequency stock transactions. The CX820 provides 20 100 gigabit per second uplink ports. The 16 downlink 100 gigabit per second ports are connected to the blades. Therefore, each blade is connected to a 100 gigabit per second port. The switching capacity is 7.2 terabits per second, and the switching latency is less than 100 nanoseconds. Therefore, the switch module is ideal for HPC scenarios which are latency sensitive. the CX820 is the only built-in OPA switch module for blade servers in the industry. For our competitors, if they want to build an OPA network, an external OPA switch needs to be purchased. In addition, the cable between the switch and the server can be quite expensive. Therefore, the cost of the entire OPA network can be quite high. As a Huawei network-developed built-in OPA switch module, the CX820 can greatly reduce networking costs. In addition, the switch module provides 4 more uplink ports than downlink ports, which saves the external switch. The extra uplink ports can be connected to other OPA devices. This way, networking density increases and the number of switches is reduced. This slide shows the comparison between the E9000 and its rival products. As we know, the HP C7000 and Dell 1000E are the most widely used blades in the industry. HP launched Synergy to replace the C7000 because the entire architecture of the C7000 is old and cannot adapt to the Intel CPU upgrade and next-generation network evolution. We can see that the Huawei E9000 has advantages in hardware specifications over its rival products. Huawei not only leads in heat dissipation design, but also in computing density. Heat dissipation design determines the evolution capability of the blades. Computing density is calculated based on the V3 blades. This is because the V5 blades do not include high-density twin blades similar to the CH140. It can be seen that 64 V3 CPUs are supported. In addition, Huawei also boasts great advantages in memory, storage, networking, and PCIe. Most industry vendors do not support PCIe expansion for blades, but Huawei does, a great advantage when it comes to switching. This is largely due to Huawei's background as a switch and router vendor. Backplane bandwidth is 32 terabits per second, which is much larger than that of other vendors. Therefore, its evolution capability towards next-generation networks is better. This is why Huawei is the only vendor that provides 3 different 100G networks for customers to choose: 100G InfiniBand, 100G OPA, and 100G Ethernet. In terms of reliability, Huawei blades support long-term stable running at high temperatures, a testament to its high reliability. The V5 blades support all series Intel CPUs. Some competitors' blades do not support CPUs of up to 205 watts and cannot be used in virtualization and HPC scenarios that require high-performance CPUs. In terms of DIMMs, competitors face problems when it comes to heat dissipation and the mainboard. Their mainboard area is small and supports only 16 DIMMs, but a Huawei half-width blade supports 24 DIMMs, and a full-width 4-socket blade supports 48 DIMMs. All series DIMMs are supported. As the number of memory channels increases, a single CPU supports 12 memory channels. As a result, the memory bandwidth greatly decreases because 16 DIMMs are not an ideal option and only 8 memory channels are used. Therefore, to achieve the optimal memory performance, memory channels must be fully used and 24 DIMMs are configured for a 2-socket blade. The E9000 supports PCIe acceleration cards in the expansion slots, and GPU or encryption cards can be installed. Then, M2 SSDs are hot swappable. In addition, the backplane supports the 200G evolution capability of a single port, which is not supported by other vendors. Rival servers of the current generation only support the maximum capability of 100G, and not all 100G specifications are supported. In comparison, Huawei supports the evolution from 100G to 200G to protect customer investments, and Huawei also supports flexible NICs. Now let's take a look at sales scenarios and success stories of the E9000 in the government, finance, education, broadcasting, and television industries. In terms of governments, we can start from the core application office systems in safe cities, also known as video surveillance. Huawei E9000 has advantages in virtualization networking in that it supports CPUs of various specifications and provides various external network ports, including Ethernet and FC ports. For example, in the Citizen Card project in Taizhou, Zhejiang Province, the customer used the E9000 to build its IT infrastructure and information platform. E9000 supports centralized management and excellent maintainability, shortening the entire information maintenance period from 30 days to 10 days. This is due to the high performance of the servers. Therefore, we can promote the E9000 for government office systems and video surveillance. In the financial industry, databases and virtualization applications are used quite a lot. Databases are a core business for bank customers. Customers place a lot of importance on reliability. The Huawei E9000 uses a passive backplane, supports operation up to 40 degrees Celsius, and is a highly reliable design. Therefore, the Huawei E9000 has advantages in reliability. In terms of database performance, a 4-socket V5 blade server supports 48 DIMMs to fully utilize the 24 maintenance channels and supports CPUs of various specifications. Therefore, database performance is high. Here is an example of China Construction Bank, one of the 4 state-owned banks in China. The bank uses Huawei blade servers to build database resource pools and big data applications. E9000 has advantages in database and virtualization scenarios in the finance industry. The success cases include ICBC and Sberbank, the largest bank in Russia. The education industry mainly involves HPC and desktop cloud. We know that some colleges and universities build HPC clusters for research and sometimes for lease when their own requirements have been met. Therefore, in education, we promote the E9000 for two scenarios, HPC and VDI or desktop cloud. The desktop cloud is mainly used for the teaching offices. The slide shows a typical HPC networking diagram on the right. The overall density of blades is much higher than that of rack servers, and many customers prefer blades when building the HPC system. For example, customers like Mercedes-Benz and PCSS in Poland have chosen Huawei blades to build an HPC system. In addition, Huawei provides built-in InfiniBand and OPA switch modules. Therefore, Huawei has cost advantages when it comes to HPC networking. One example we can look at is Zhejiang University, which used the E9000 to build a high-performance cloud platform. Other cases include PCSS in Poland and Southeast University in Nanjing, China. PCSS is Huawei's first liquid-cooled site globally. The PCSS project was listed in the global top 100 HPC cases. Broadcasting and TV scenarios mainly involve video editing and animation rendering. In this industry, the E9000 is sold with Huawei Fusion Sphere as a whole. The main advantage is that the E9000 features high integration and supports GPU expansion. Let's take a look at an example of a customer in Liaoning, China. The customer used the E9000 to build a media playback control platform mainly because of its high integration. Other cases in the media include Brazil's Globo TV and Illumination MacGuff for video rendering. Some other TV stations include Hunan TV Station and radio and television stations of Jiangsu Province. Now let's take a look at some cases. First is Mercedes-Benz, one of 3 luxury car manufacturers in the world. This case is about the R&D department of Daimler, the parent company of Mercedes-Benz. The department chooses Huawei servers to build an HPC system for computer-aided engineering, including fluid mechanics simulation and collision simulation. All of these scenarios require quite a lot of computing. The project is in its 4th phase and uses Huawei rack and high-density blade servers for Daimler's HPC system. In particular, the Huawei E9000 blade servers, which feature high density, have more than doubled the cluster density of Mercedes-Benz and improve its performance by up to 50%. The Burj Al Arab Hotel is a globally famous hotel managed by Jumeirah, a world-renowned luxury hotel operation company. Jumeirah uses Huawei servers mainly in its IT office systems because of the high density and good manageability. Huawei servers have helped them reduce cost, save space, and improve the overall operations efficiency. Illumination MacGuff is a French company that has been acquired by United States Universal Studios. It's best known for its Minion series films. As we all know, animation making needs a rendering farm for animation rendering, which requires a lot of computing resources. Illumination MacGuff uses the E9000 server and is the largest customer of the CH140 high-density blades. The blades save more than half the equipment room space. In addition, the excellent manageability greatly shortens deployment time and improves animation efficiency by at least 20%. Another reason that Illumination MacGuff chose the E9000 is that it is headquartered in Paris, where every inch of land is as precious as gold. The area of the equipment room is limited, and the computing density is an important factor to consider. The E9000 provides a high-density solution. Poland PCSS is a case of liquid cooling. It is a university in Poznan, Poland, and the supercomputing center of Poland. PCSS chose our liquid cooling solution to build an HPC system. In 2015, it ranked in the top 80 of HPC rankings. In addition, this solution helps the customer greatly reduce electricity costs, and its PoE is less than 1.2. Sinopec uses Huawei Fusion Cube to build the world's largest single-cluster SAP HANA system. SAP HANA is an in-memory computing system and can greatly improve the average service processing speed compared with the solution of storing data on disks. It is also an OLAP data warehouse. The last case is the China Railway Corporation. Its core system is the scheduling system and has high requirements on reliability. We have had successful cooperation with the China Railway Corporation. In 2015, the power of its entire data center failed due to an equipment room fault, and the temperature of its equipment room increased rapidly. Other vendors had to power off their servers in order to avoid breakdown. Huawei engineers arrived at the site and determined that Huawei servers could still work properly in that environment. As a result, Huawei servers were the only servers that continued working reliably until the next day. This proved the overall reliable design of Huawei products, and the customer purchased more E9000 servers from Huawei. That's all for today's presentation. Thank you so much for your time, and have a great day.